The role of the surge arrestor is to protect other components from overvoltages due to lightning or switching in the power system. Under normal conditions, the surge arrestor acts as an insulator. When overvoltages occur due to lightning or switching in the system, the nonlinear characteristics of the metal oxide block cause the overvoltages to be led to Earth through the surge arrestor. Afterwards, the arrestor resumes its previous standby status. In the event of an extreme overload, excess pressure builds up in the arrestor. The pressure relief valves of the porcelain-housed arrestor open, and the gas is led to the outside, thus preventing the porcelain from shattering violently. The polymer-housed arrestor lacks an inner atmosphere, as the silicone rubber insulator is molded directly onto the interior. In the event of an overload resulting in a short circuit, the interior is held together with the help of aramide fiber windings when the insulator is punctured. Regardless of which arrestor is used, it fulfills its protective role when these unforeseen overloads occur and can easily be replaced. The conventional porcelain-housed arrestor X-Lim is available for IEC line discharge classes 2 to 5 and system voltages up to 800 kilovolts. The polymer-housed arrestor PEX-Lim is available for IEC line discharge classes 2 to 4 and system voltages up to 420 kilovolts. PEX-Lim for higher system voltages can be produced upon request. Compared to conventional porcelain-housed arrestors, PEX-Lim provides additional benefits. It is more compact, lighter in weight, and able to withstand transport better, and provides better personal safety. It's also superior to porcelain arrestors in polluted environments. No matter which type of arrestor you choose, the metal oxide block is the common denominator. The primary component is zinc oxide. The powder that is produced is pressed into blocks under high pressure. A sintering process follows. During this process, the block gets smaller and changes color. An insulating coating is applied to the outer surface. The blocks are heat-treated, after which a thin layer of aluminum is applied to the electrode surfaces in order to obtain good electrical contact between the blocks. All blocks go through various cycles of energy testing, in which the energy is higher than international standards stipulate. In other words, it's a demanding test that requires a high uniform quality in the blocks. The blocks are classified, which guarantees that the finished arrestors live up to their protective data. During pre-assembly, the constituent blocks are stacked with spacers based on the electrical design of the respective X-Lim unit. The height of the interior is remeasured, after which the unit is equipped with a sealing cover on each end. Before the leakage test, the unit is vacuumed and filled with clean, dry air with a small quantity of helium. A helium spectrometer is used to detect any leaks. During assembly of the PEX-Lim arrestor, the column of blocks is secured with glass fiber loops, giving it good mechanical properties. Aramide fibers are wound around the column of blocks to provide maximum safety in the event of a short circuit. A process follows in which the interior is primed in order to obtain good adhesion during molding. The method is completely free of environmentally harmful substances and thus follows ABB's environmental policy. After drying, the interior is heated in an oven before final molding. Each unit is marked with its individual electrical design to ensure that they are mounted in the correct order when several units are connected in series. This marking follows the applicable IEC standard. Packing material is environmentally friendly. ABB's arresters are simple to install and require no special tools. It is important that the markings are followed so that the established electrical properties are fulfilled. For high system voltages or for arresters with strict leakage path requirements, simply connect 2 or more units in series. If a grading ring is included, it must be fitted in accordance with the instructions. Grading rings even out the electrical field so that voltage is distributed evenly along the entire length of the arrestor. This leads to a long service life. If properly installed, the arrestor is practically maintenance-free throughout its service life. PEX Link is the name of ABB's transmission line arrestor concept. The concept is based on the PEX Slim arrestor with specially adapted connections and cables for existing lines. Earthed overhead shield wires, optimally located in the towers along a power line, often provide good protection against lightning strikes across the line insulators. A basic condition, however, is that the towers are sufficiently earthed. When the power line passes through areas with high earth resistance, the protective capabilities of the overhead shield wires are reduced. In this situation, the risk of back flashovers across line insulators is significant. Any strike across a line insulator registers as an earth failure. The current is switched off at the station and then reconnected. A power outage has occurred. Installing PEX Link parallel to the line insulators protects them from back flashovers. If the tower is struck by lightning, PEX Link shunts the overvoltages out on the phases. In nearby towers, PEX Link then shunts out the overvoltages from the phases to earth. Thus, PEX Link protects the line insulators from the lightning strike and the system from earth failure. This improves the reliability of the power line and ensures that the end customers receive a uniform, constant supply of energy without a power outage. PEX Link is a perfect design for compact insulation lines. Placing PEX Link in the top phase of a compact 400 kilovolt line eliminates the need for the traditional overhead shield wire. ABB has applied PEX Link for system voltages up to 800 kilovolts. An entirely different application for surge arresters is the tailor-made variant for HVDC facilities, in which the arrestor keeps the overvoltages to a minimum. This allows you to choose a lower insulation level for the components, thereby reducing costs. ABB's range of measuring instruments includes the X-Count-A surge counter, the LCM2 leakage current monitor, and the X-Count-2 monitoring system. Regardless of which measuring instrument you choose, the surge arrestor must be equipped with an insulated base in order to ensure it is insulated from earth. The surge counter X-Count-A provides information on how often the arrestor has been in function. It can be applied to all types of gapless metal oxide arresters. The portable leakage current monitor LCM2 can be used to measure the resistive leakage current through the arrestor. This measurement method is best suited for existing facilities. For new installations, it is possible to install ABB's new advanced monitoring system X-Count-2 for continual status monitoring. In addition to its surge counter function, X-Count-2 also registers discharge amplitude, date, and time, as well as having the option of measuring the total leakage current. Measurement results can be stored in the sensor unit, and the information can easily be retrieved and read using a wireless handheld unit. Analysis can be done on-site or via a PC for statistical processing. There is also a version of XCount2 that measures resistive current, which is an indicator of the arrestor's condition. XCount2 is a superior alternative for continuous monitoring, as many customers have already discovered. For those who desire safety and security for various components, and especially the end consumer, ABB surge arresters are the natural choice.